Hey guys, today we're going to review some conic sections, and those are the parabolas and hyperbolas. And I'm going to warn you now, this is probably going to be a little bit long, so if there's a portion that you remember, you're fine to skip ahead and skip to the things that you need help with. So we're graphing a parabola or hyperbola written in standard form. So first thing we need to know is the equation of a parabola. And so we know parabolas probably better when you're using your vertex form where it looks like this. But we also have this form for a conic section, and what this helps us do is it helps us orient either up or down or side to side. So these are the two equations for standard form of a parabola. Again, vertical parabolas can open up or they can open down, and horizontal parabolas are going to open from side to side. And so if I look at this standard equation, the vertex or the center, we used to call it center on our other types of equations, but now we're looking at a vertex, and that's just going to be at h comma k. And then we have something called direction, and basically all that's saying, am I opening up, am I opening down, am I opening left, or am I opening right? And so the big thing here is this p. The number that's in front of your not squared term is going to help you decide what direction it opens. If p is a positive number for a vertical parabola, you're going to open up, whereas if p is a negative number, you're going to open down. And that's the one we're used to. A negative in front makes you open down. And in a horizontal, same idea. If you have a positive number, if p is greater than 0, you're opening towards the right, so like this. And if p is a negative number, you're opening towards the left, so like that. Okay, and that p, all that represents is the distance from the vertex to the directrix and the distance from the vertex to the focus. So if you take a picture of this, if I had my parabola, it's just going to be centered right there. Here's my parabola. And again, this is considered a horizontal parabola because it's opening to the side. Now, on that parabola, here's your center or your vertex, and then you have two special points, and that one of them is going to be a line, and this one's called the directrix. And then you also have a focus. And with that focus, your parabola opens around your focus and away from your directrix. And so if I look at this picture, that value p is just this distance from the vertex to the directrix, or from the vertex to the focus. And so again, when you have these, it'll still work for an up and down parabola, and it still works for a side to side. It's just you have a negative p value, and so you flip-flop your locations. So let's do some practice problems. We're going to graph the parabola, label the vertex, focus, and directrix. And for this first thing, if I look at this guy and I see the x squared, this is what I'm used to. This is a regular parabola. It's going to open up because there's no negatives inside. And so you are more than welcome to make the XY chart and plot some points and get your picture that way. But if you want to graph it using your conics knowledge, we know that this is going to open up. It's vertical, so it opens up. I know it's vertical because x is squared and there's no negatives. And then I know that my vertex, or my center, is at 0, 0 because I'm not adding or subtracting anything to the x or the y. So my vertex is hanging out at 0, 0. And then if I want to figure out what my p value is, I look at the thing that's next to the not squared term. So my y is my not squared term. This number right here, that's equivalent to 4 times p. If you notice in the equation over here, there was a 4 built in. And so if I just want to find p, I need to set that whole thing equal to 4p. So if I just solve that guy out, I get 2 equals p. And so I know the distance from my vertex up to my focus, or my directrix, is 2. And since I know it opens up, I know my focus is going to be upward, so my parabola can open up. And then I know my directrix is going to be down 2, since it opens away from your directrix. And then you just try to make your line. And this is going to be horrible, I can already tell. But there you go. That's the idea behind graphing. Okay, and again, you can graph your vertical ones, your regular ones, using an XY chart. That's fine. When they become the horizontal, that's when it gets a little bit more tricky, and I find it more easy to figure out the pieces from the conics form. So if I look at this guy, again, I can tell that this one is going to be horizontal because it has a y squared term. And since it has a y squared term, that's not the thing we're used to, so it's going to open side to side. And I know that it's going to open to the right because my p-value, the number over here, is not negative. So it's going to look like this guy. And so then I can do the same thing. My vertex on this one, it does have a vertex that's got shifted. I just look the same way I did on a circle or an ellipse. And I know that this side flips, so my vertex is going to be at -3, +4. Okay, watch out that your x coordinates with your x and your y coordinates with your y. So I'm going to go plot that. There's a line on my screen, it's really hard to see that. And then I'm going to go look for my p-value. And so again, you look by the not squared term and you set that equal to 4 times p. Divide by 4, divide by 4, so I'd know that p is equal to 4. So I know that in 4 either direction, 1, 2, 3, 4. And the reason I know it's side to side is because I already figured out it was horizontal. And since it's opening towards the right, it's going to open around your focus. So this is your directrix. And if you wanted to label that directrix, remember, if it's a vertical line, it's a vux, you're going to have x equals some number, and that number happens to be at -7 if I can read correctly. Okay, and then I go ahead and I graph my parabola. And again, you could plot points if you wanted to. This one's kind of weird because you'd get 2 x's for every y. But, you know, it works. Actually, 2 y's for every x. I don't know what's going on. Okay, so that's how you graph a parabola. Now, what happens if they want you to write an equation? Well, the first thing I always do on these is draw a picture. So if I draw a picture of this guy, it has a vertex at 2, -5. And it has a directrix at x equals 6. So 1, 3, 4, 5, 6. Now remember, x equals 6, that's a vux equation. So it's a vertical line hanging out at x equals 6. And so that's my directrix. So I always know that my parabola is going to open opposite from my directrix. It opens away from the line, which means this guy is opening left, and it's going to be horizontal. So at this point, I could already fill out part of my equation. I already know that my y is going to be the squared term. And I already know that there's going to be a 4 times some p-value, and then my x coordinate squared, not squared, because we're obviously a parabola, duh. So now I can use the pieces that I do know. So I do know my vertex, so I can just plug in my 2 and my -5. Remember, minus a negative is going to make it a positive. And so all I'm missing here is my p-value. And the easiest way to find the p-value is to figure out how far is my vertex from my directrix or from my focus. And so if I counted this out, this one is going to be 4 units. 1, 2, 3, 4. So all I gotta do is plug in a 4 in here, simplify what I can, and this would be the equation of this parabola. Okay, and so that's parabolas in a nutshell. We're gonna go ahead and look at hyperbolas. So a hyperbola is basically 2 parabolas stacked together, so you have them where they're vertically oriented, where they are opening up and opening down, and you also have the horizontal oriented ones. They have a horizontal transverse axis that open side to side. And so again, they look like 2 parabolas stacked up, and these are the equations for them. You're going to notice they look very, very similar to the equations for an ellipse, but the big difference here is that there's a minus sign in between. So your x's and y's have different signs. And the center is still the same thing. When you're finding the center, you look for your h and your k. If you notice, it matches with the x and the y still. And the other thing here is that the a always is under the first term and b is always under the second term. The thing that determines if you're vertical or horizontal is y first or is x first. So if y is first and it's up and down, it's y direction, whereas if x is first, it's horizontal. And the other thing you need to know are the slopes of your asymptotes, because when you draw these guys, and there's a picture on your paper somewhere, where to go? So this picture, you have asymptotes that tell you exactly how to plot it. And in order for you to find the slopes of those asymptotes, you need to use a and b. So the slope of the asymptotes of a vertically oriented hyperbola are going to be plus or minus a over b. So I'm going to take the square root of this over the square root of this. One of them will be going in the positive direction, one of them will be going in the negative direction. Horizontal is almost the same thing, it's just now it's b over a. So basically you're taking what's underneath the y over what's underneath the x, and it just changes because my x and y moved. Okay, so let's practice graphing these things. First of all, we're going to label the center and the vertices. And when I say vertices, I just mean those points on the branches. So you're going to need some other points here, but you only need to list 2 vertices. So when I look at the sky, the first thing I always try to do is determine its orientation. And I know that this one is vertical because y is first. So if y is first, it's vertical. If x is first, then it's horizontal. So I know that this guy is going to open up and down. Now I need to figure out how. The center on this one is going to be at 0, 0 because there's nothing next to your x or your y. So I already know that my parabola is centered around the origin. Okay, now I'm going to go ahead and name my a and my b. And remember, your a is always under the first thing, your b is always under the second thing. So for this one, your a is going to be the square root of 9 or 3, and this guy is going to, b is going to be the square root of 25 or just 5. And I'm still going to use it in order to plot in that particular direction. You just have to kind of be careful here. So I know I need to go out 3 in the y direction. So 1, 2, 3 from that center. And then I'm also going to go the negative direction. Then I'm going to do the same thing with my b value. So I'm going to go out though 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Can't read my numbers. So now what I'm going to do, it's kind of weird. I'm going to go ahead and put a box in here. And this box is only for us to help graph those asymptotes. But it's very useful when graphing those asymptotes. And so what I did is, if I was drawing an ellipse, I basically put a box around the ellipse. And so once I have my box, I'm going to use the corners of my box in order to draw my asymptotes. And so when I do that, you can kind of see the direction it's going to go. And I completely missed the corner on that one. Good job. And so those are my asymptotes. And again, since this is a vertical one, they should have a slope of a over b. And so if you looked at it, it goes up 3 over 5. That's a over b. Okay? And now I can go ahead and graph my hyperbola. And so I know it's vertical, so I'm going to go ahead. This is going to be the vertice, and then I'm going to try to follow my asymptotes as much as I can. That is the opposite of what I should have been doing. Close, close, close. It's really hard to draw on this. Close, close, kind of got it. Yeah, I win. So I know my center, my vertices, again, are the ones that are actually on the graph. So it'd be this guy, so at 0, 3, and at 0, negative 3. Okay, now what happens if it's not centered at the origin? Or you get something crazy that looks like this. This guy's not in standard form. Our standard form always says equals 1. And so in order for this guy to equal 1 on this side, I'd have to divide every single piece by 100. And so really what my equation is going to look like, this should reduce down. So if I divided both of these by 25, I'd be left with 4 in the bottom. If I divided this by 4, I'd be left with 25 in the bottom. And that's usually what happens. So the equation I'm graphing in standard form looks like this. And so now I'm going to go through and name all my pieces and all the interesting parts. So the first thing I know is that this is a horizontal hyperbola because x is first. If x is first, it's horizontal. And that means it's going to be opening side to side. The next thing I know about it is the center. I take this guy, so 1, the one that's next to the x, and then the y, and remember I flipped their signs. So this guy is actually centered at 1, negative 2. And then I can name my a and my b values. So remember, a is first. Doesn't matter what's first, but a is the number underneath the first part. So square root of 4 is 2, and b would be the square root of 25 or 5. Okay, now that's going to help me know how far in each direction to go. So in the x direction, since it's under x, I'm going to go 2, 1, 2, and then 2 the other way. And then I'm going to do the same thing for y, except for now I'm going to go up 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, and then I'm going to use those points to make me a little rectangle. Once I have my rectangle, I can connect the corners. Wow, I get worse and worse every time I do it. That's terrible. Okay, so I connected my corner, sort of. Here, maybe this will work better. Connect my other set of corners, and again, if you look at these asymptotes, they're going to have that slope of b over a. They would go up 5 over 3, or minus 5 over 3. Okay, And then the last thing I have to do is go ahead and draw my branches in. And so when I draw my branches, again, this is a horizontal. So you're going to take these parts of your rectangle and then try to follow your asymptotes out. Oh, see, I'm much better at drawing it horizontally, apparently. And so looking at this picture, that then means my vertices are over here where the lowest or the most left or right piece of your branches are. So I have one at, I believe that's 3, -2, and then my other one is at -1, -2. Okay, and that's how you graph something that's not in standard form. I have to make it into standard form. Last but not least, if we were given the graph and we need to write the equation, we need to go ahead and find the missing pieces. And so I always start these by actually writing out that equation. I know it's x minus something. Well, actually, I don't know that yet. Let me figure that out for you. So the first thing is I look and see if it's horizontal or vertical. My branches are opening side to side, so I know it's horizontal, which means that my x comes first. Okay, I'm trying to get ahead of myself here. So since it's horizontal, I put my x first over something minus y minus something over something equals to 1. Okay, that's just our equation because I know it's horizontal. The next piece is I'm going to go ahead and find my center. So my center is here at 2, 3, and remember if we'd have to change that sign if it had been negative. And now the last piece is I need to go ahead and find my A and my B. There's 2 ways to do this. You can use your asymptotes or you can just count out on your box. So if they give you your box, hooray, all I have to do is look at this and say, in my x direction, I go 1, 2, 3. So that number underneath x, my A, is going to be 3 squared, or 9. And then when I do the same thing for B, I go up 1, 2. So that means the value I'm going in the y direction is 2, so 2 squared is 4. And again, you could have used your asymptotes if you wanted to remember those. You're looking, I went up 2 over 3, and since it's horizontal, that means that my B is 2 and my A is 3, because that's the asymptote equation. Okay, and that's all I got for you. Hopefully when we go over some more parabolas and hyperbolas tomorrow, you feel confident and you're ready to kick some more conics.